Welcome, guys. Team, I think it's 10 already. Do you want to start now?
Yes, I think we can start now. So,
Yep.
but I want to make sure. Oh, there are already like 153 students attended. So, do we need to wait maybe some more time to get let more people
Welcome,
get in, or
guys.
we can just?
Team, I think it's 10 already. Do you want to start now? All right,
Yes,
so I think
so
we should wait for a few more minutes. Jeff?
there are already like 53. I can hear the echo. So
Yeah, it's from Jeff.
some more time to get.
It's from Jeff.
Okay.
All right, I think let's just wait for an extra 5 more minutes. Then we'll start. All right.
Sure.
Yep. Hi, Tim. I think we're good to go. We're streaming on YouTube already.
Okay. I see there are, I think it's a good time to start because we already reached like 200 people. So it's a good number. So, okay. So Hi everyone. So thanks very much for Binance and to organize this like master class. So I'm Tim from White Matrix, and I'm also the CTO of White Matrix. So today I'm going to my topic is basically decentralized applications, so DApp, namely DApp. So since I'm a technical guy, so I probably will introduce these things in a very technical way, but I want to try to make it as comprehensive as possible. So so here is today's roadmap or content. So I will there are basically 5 major chapters. So first one is from P2P trading to decentralized computation. The second one is the introduction to programmable blockchain network. Third one is the introduction to the main title, decentralized apps. The fourth one is deep dive on the EVM stack. So the fifth one is how to write a decentralized app in ChainIDE. So basically all these 5 concepts is how the first two chapter is basically how we go through into the state of from a P2P trading network into a programmable blockchain network, right? And then the last 3 chapters are more about the technical details and how to write a DApp in ChainIDE. Okay, so let's do a quick review on the old-fashioned blockchain technology. So basically, blockchain is best described as a public database that is uploaded and shared across many computers in the network, right? So block refers to the fact that data and the state is stored in sequential batches or blocks, right? So if we want to send any cryptocurrency to someone else, the transaction that need to be added into block for it to be successful. So chain refers to, okay, so each block needs to be connected with the data integrity check, right? So that's why it is named blockchain. So that's also the how this idea or the term is proposed in the paper of Bitcoin. So these are all the Bitcoin idea. Okay, so how the blockchain workflow works, it looks like this. So someone requests a transaction, right? And then the transaction is broadcast to the P2P network, and then it is calculated, validated. And once it's verified, the transaction becomes part of new block, and the block is added to this blockchain, and then the transaction is completed. Okay, so this is a simple workflow, right? So this workflow actually still applies to all almost every modern blockchains right now. So there are some fundamental blockchain technology terms. Basically, the first 2 POW, proof of work, and the POS, proof of stake, is usually called consensus mechanism. So this is a key part that's to make sure every node in this network share the same consensus. Basically, we know that POW is basically you need to solve a difficult math problem or puzzle, right? And anyone who wants to add a new block into the chain need to solve that, need to be the first one to solve that. It causes some problem because it becomes a really wasteful competition of the computation power, right? So people around the world, right, build up their computation cluster, or even some people use the nuclear power to do this computation. It's just saying, okay. But for proof of stake, it's actually solved this problem in I think in a more elegant way, that there's always only one node that is selected selected by the network to do the mint or forge of the new network new block generation. So basically, there are some controversy between these 2 consensus mechanisms, but I won't go that deeper today. So I will just list these 2 here. After the consensus is created, then the new blocks are broadcasted into the network, checked and verified and updated status for everyone. So that's basically how a new block is generated. So what's more? So beyond this, we can see some potentials of the blockchain just from the idea of Bitcoin, right? So the first one is, okay, we have this proof of work validation process, right? which is basically decentralized computation. And the P2P trading, which is basically the online payments, right? So nowadays, like Bitcoin is the biggest. If we combine these together, we can see that even from the era of Bitcoin, blockchain networks has the potential to become a decentralized payable computation engine or services. So what's this? What's a decentralized payable computation engine? So it's basically AWS or like GCP or all these like cloud service providers. So, but blockchain can do all these things they can in a decentralized way. So which is the way that benefits more for small business and people, right? Because everyone is equal to attend into this computation and use everyone can contribute to their computation power. Okay, so but since even though we have this potential, so how did it come true, right? So we need to talk about the smart contract. So starting from Ethereum, we first introduced it's not first, but very first introduction of the idea of a smart contract. So Ethereum basically is an open source public blockchain-based distributed computing platform. This is quoted from their white paper. So they have the feature, it's a very important feature, smart contract functionality, which facilitates online contractual agreements. So basically you can write your own program or you can write your own applications in the blockchain in a decentralized fashion. The smart contract are just a program run on blockchain networks. Okay, so what's the difference? Why it's needed? So beyond the financial transactions, previously Bitcoin is just a decentralized P2P transaction engine. Now it becomes decentralized P2P transaction engine computation engine. So it makes the blockchain network programmable and extensible. So that's why this is the idea of blockchain network currently is very fascinating, because we have like infinite, the possibility on the blockchain are infinity, right? And now most blockchain, I think only Bitcoin is not. So most blockchain we know are programmable blockchain networks. For example, Ethereum, like Binance Smart Chain, Polkadot. So here is the graph. Here's basically like two pictures show what's the difference, right? So each node is only a coin here, but in the modern like blockchains, each node can have different functionalities. It can be a coin, which makes sense for a P2P transaction, or it can be an online application, or it can be a validator, or maybe a audit authority. It can be a like marketplace. Okay, so how is the computation on the blockchain achieved? Basically, the idea is introduced is a blockchain virtual machine. So in the programmable blockchain network, there's always a single canonical computer, such as Ethereum virtual machine, namely EVM, right? So everyone on this network agree on its states. Everyone keep a copy of the states of this computer, and everyone can perform after computation and broadcast it. So all other nodes on this network will do the thing like verify, validate, and execute this computation. So that make sure the computation is not malicious, right? The state change in this EVM will be committed and propagated throughout the entire network, just like the Bitcoin payments or like transfer transactions, but just in different forms. Now we can do like computation. We can do like logic. We can do arbitrary program. We can arbitrary program via this validator code. Okay, so there are two important attributes of the blockchain virtual machine. The first is cryptographical verifiable. So transaction is actually signed by the original executor to ensure that all transactions are executed with proper permissions. For example, like we always talk about like Alice and Bob example, right? So as Bob can send a digital assets to Alice's account, right? And Bob will just sign this with his own private key, and all the nodes on the blockchain can validate via the public key, but they cannot modify the content, and they cannot like there's only Bob can send the digital assets from his own account, right? The other thing is immutable, right? So once the transaction are verified, valid, added to the blockchain, they cannot be tampered. Otherwise, the blockchain hash will become different, and all these blocks after the invalid block will become invalid too, because the previous hash is become invalid. So in order to make sure the things happen, we also need a native cryptocurrency. It's like Bitcoin on the Bitcoin network. So we also need this kind of native cryptocurrency. So the purpose of native cryptocurrency is to allow the existence of a market for computation. Such a market provides an economic incentive for the participants to verify execute transaction requests and to provide a computation resource to a network. So everyone can become a service provider, everyone can become a customer of the computation service. So the official cryptocurrency of the blockchain is when you do a send or broadcast a transaction, you can offer some amount of like Ether or a BNB, namely the cryptocurrency in Binance Smart Chain, and award for whoever verified, execute, and committed transaction to the blockchain. So the amount of the function of the amount of this cryptocurrency, for the courier or the validator received is the length of the computation, which is namely the gas fee, right? So if I have a very long program to run, I need to pay more gas fee because the length of the computation is quite long. Okay, so the next step is what are the decentralized applications, right? So basically, if you want to develop a application on blockchain network, it's now possible because we have all these smart contract available there. So the developer will do first upload their program smart contract into the canonical virtual machine, like EVM. And then all the users on this network can execute the function of the program. So it's already become a service, right? So it's, for example, if we, let's imagine we have a vending machine, right? The vending machine is basically has two functions. So an arbitrary person can come and put their assets into this vending machine and give this assets certain like price tag, right? So, and anyone who come to the vending machine can purchase the assets in the vending machine according to the price tag. So basically, this already become a application even without the front end interface. So that's how the decentralized application is created. So what is decentralized application? So it's basically applications back-ended by smart contract on the blockchain. So anyone can deploy a set of function smart contract into this network, and the blockchain is used as a business logic and a data layer, right? And any user then can interact with this application. So with the power of the smart contract, so now arbitrarily complex user-facing apps and services are now built, such as marketplaces, financial instruments, and games. So we all know that these are four very unique and different applications now, famous applications now exist in the blockchain world. So first is a PancakeSwap, right? So we all know that yesterday the PancakeSwap has a really it's a really good hype, and it's actually the trading volume already exists greater than this one, which is Uniswap. Previously the biggest DEX in Ethereum, and this is CryptoKitten. So this is one of the first. I would say it's a blockchain game. So basically, you can just raise a cat, and you can just trade the cat with other people's cats, right? And the last one is basically the recently we know it's NFT. It's basically you can just link a token of the real world art or maybe a digital art into a token in the blockchain world, right? So for example, like the Rick and Morty, so all these tokens, all these NFT tokens already sold up to, I think, hundreds of millions of dollars. So also there are banking, payments, transfers, healthcare, and voting, IoT, music, real estate. So basically anything you can think of, you can just build a application on top of it. So okay, so let's review some terminologies. So the first one is a blockchain. So it's basically the sequence of all blocks have been committed to the network in history in the history of network. The second one is basically we mentioned two different native cryptocurrency, which is Ether and BNB. It's just a native cryptocurrency of Ethereum and Binance Smart Chain, and we will use them later in the practice. Blockchain virtual machine. So it's basically the global virtual computer whose states every participant on this blockchain network stores and agrees on. Any participants can request the execution of other code execution on the BVM, and the code execution changes the state of it. So for example, so EVM for Ethereum, BSC, and also like customized Docker environment for Hyperledger. Nodes. So it's basically the real life machines and servers which are storing the blockchain VM states. And accounts is individual user identity on the blockchain network where native cryptocurrencies are stored. And the transactions are just the formal terms of the request for the code execution on the blockchain VM. So for example, if you want to run a code, send X, run a code, run a program, and transfer some assets or transfer some cryptocurrency to some other people's account. These are all transactions. Okay. And blocks, as we mentioned before, is just a batch of transactions that are mutable, complete, and cryptographical verifiable. Smart contracts are basically a reusable a code snip, which a developer publishes into this EVM memory. And the decentralized application, as we mentioned, is just the applications that use smart contracts as their backend. All right, so we already talked about, okay, so how the blockchain would evolve from a pure P2P network into a online payable decentralized computation platform. So now we go one step deeper. We want to talk about more detail about decentralized apps. So how to build a decentralized app? So it's built on a blockchain network, that's for sure. It has smart contract as their business logic and the data layer. But for people to access this application, we also need to use some other technology to build the front-end user interface. Now, also, all these APIs are quite open so that everyone on this network can access. So this is basically how this is basically a structure of like how the UI is interacting with the blockchain backend. So basically, it will do two types of calls. So one is get, which is just to read the data from the EVM. The one is call, which is just to write it into the EVM, and that will alter the state of the EVM. And basically, in the front end, you can just use whatever like a programming language like HTML, CSS, JavaScript, Ruby, Python to write the front end, but the back end is always the smart contract. All right, so there are some definitions of decentralized apps. So first of all, it's decentralized. So they're independent and no one can control them. That's quite important for that. Second one is the deterministic, which means that the same input, the same action always result into the same output. Given the certain time, given the same state. So if we apply the same input into a certain block with the same action, we always get the same output. It's Turing complete, so basically, theoretically, they can perform any action. And that's also the trend we see in recent decentralized development, that not only games, we see games, we see like marketplace, we see even a lot of like big companies are also use decentralized apps to build their reconciliation system. Okay, so the last one is isolated, so that bug of a single smart contract won't affect the whole network. And there's also zero downtime. And theoretically, there are still chances of the downtime that if the entire network died, but as long as there is still like nodes in the network, there's zero downtime. And also it's totally private. So there's no real world identity involved in this situation. And also it's resistance to the censorship, so that data stored on the blockchain is immutable and indisputable. And also it's trustless computation verifiable behavior, so that smart contract can be analyzed and guaranteed to execute the predictable ways without the need of a centralized authority. This is not true in the traditional modes. For example, when we use online banking, right? Online banking system, we have to trust the financial institute so that they will not misuse our financial data or temper records or get hacked. But if they betray your trust, then your data is lost, so your money is lost. Okay. There are currently some issues with current decentralized app, so especially in the Ethereum blockchain network. So the first one, but I also listed some like potential solution or like attempts people try to solve these problems. So first one is maintenance, so that decentralized apps can be harder to maintain because every time you publish your code into the network, it's immutable, right? So there's no chance for you to, okay, I want to do a code commit or do a code change to fix a bug. No, you cannot. You can only discard this version and publish a new version in a new contract address. So that's quite hard to maintain, but there's already like solution for like tooling for contract migration. Also like performance overhead, right? So there's huge performance overhead and scaling is hard because every transaction need to be validated by a number of different nodes. So the solution is like what Binance did is the smart chain. And also there are also potential solutions like layer 2 is currently being developed. Network congestion is similar to this situation. It's basically the result of the performance that there's currently Ethereum network can only like process like 10 transactions per second. That's quite slow for a big network, right? So solution is also like, as we mentioned, the smart chain and the layer 2. I think BSC did a really good job in this sense that it's quite fast. It's quite fast network because it's a lightweight smart chain network, a smart chain that only execute the smart contracts, right? So basically, I think that's the reason that a lot of users currently now are switching to BSC. And also user experiences is that it's hard to engineer the user-friendly experiences because the tooling, the blockchain backend or the blockchain infrastructure is very hard to use, right? So that's why we need toolings and web services like what Mencius did. We have already been exploring in this area for quite a long time. So later on, I will just introduce some useful tooling for you guys so that we can accelerate the decentralized application development. So basically, this is the comparison of two different fashions, so centralization and decentralization. So I won't cover these in details, but the PPT is there for you to take a look. Okay, so let's go to the next part, which is the Ethereum and which is the account system of Ethereum and the BSC. So the first one I want to talk about is there are two different types of accounts. So the first one is externally owned account types. So it's basically controlled by anyone with a private key. So for example, if I'm a user, I want to join the network. Let's say I want to join at BSC. I just need to create a private key, and then I can join it. So that's basically very cool, and it's basically generally public available network for everybody can join. The other one is the contract is basically a smart contract deployed to a network that is not controlled by human. That's once the smart contract is deployed to the network, then all these transactions will follow the code logic. both type of accounts can receive, hold, and send the cryptocurrency and tokens, and interact with deployed smart contracts. Okay, so there are some basic ideas we need to know before we proceed. So the first one is externally owned account. If you create an account, as I said before, it costs nothing. You just need to create a key pair, right? And you can just initiate the transactions. Transactions between externally owned accounts can only be token transfer. So that's the same as Bitcoin. That's basically Bitcoin idea. But a contract is the new idea that Bitcoin doesn't have, is that creating a account that of the contract will cost some money because you are actually using the network storage and computation power. And a contract can only send transactions in response to receiving a transaction, which means that the transaction is only triggered by a function call of this code. Transactions from an external account to a contract account can trigger code. That's what I just said. So you can just basically, the contract is the code that's deployed to the blockchain, which become part of the lore of the blockchain world. Okay, so there are 4 fields of this basically Ethereum or the BSC account data structure. So the first one is a nonce. So nonce basically is a counter that indicates the number of transactions sent from the account and ensure that the transaction only processed once, right? So in a contract account, this number represents the number of contracts created by this account. Okay, and the second one is a balance, so which basically the amount of money in this account. Third and fourth one are third one is the storage hash, which is just a hash of the account storage, and the fourth one is code hash, which is just a hash of the EM code. So these storage hash and the code hash only exists in the contract account. So for external account, you don't have these 2 fields. Okay, so external accounts and key pairs. So what's the relationship? So an account is made up of a cryptographic pair of keys, basically a public key, private key, right? So you need to sign your transaction with a private key, and other people can use a public key to validate that transaction. So you never really hold any cryptocurrency. You hold the private keys. The funds are always on the blockchain network ledger, and you can use your private key to manage your assets and funds. So this is basically how it works. So as I just said, you just the transaction is actually encrypted by a private key and then validated by the public key. Okay, so transactions are cryptographically signed instructions from accounts, right? So an account will initiate a transaction to update the state of the blockchain network, right? So for example, if I want to transfer one BNB from account A to account B, then the world state will change because, for example, account A currently has 10 BNB, account B has also has 10 BNB. So next state, it's state T+1. So account A have 9 BNB and account B have 11 BNBs. All right. So a submitted transaction includes the following information. So the first 2 is basically the receiver and send. So the first one is the recipient is the receiving address. The signature is the identifier of the sender. So we basically want to identify the receiver and the sender. The third one is the value, right? So the amount of the cryptocurrency you want to transfer from sender to recipient. The fourth one is data. So it's a optional field. So if you are executing a smart contract code snip, then this one will be, you need to specify. So what's the function and what's the parameter you want to send to the smart contract to invoke it. Otherwise, if you are doing something like a transfer, or you are doing something like query, queries need this one. But if for transfer, you need this field. So gas limit is basically the maximum amount of gas units that can be consumed by this transaction. So basically, you set the upper bound. So I only have this money. right? So gas price is the fee of the sender pays per unit gas. So with gas limit and gas price, so the EVM will just calculate, so what's the actual gas it will consume. So that's how it works, right? So a transaction starting from worst state, and it specifies the gas price and the gas limit. And okay, the EVM will just receive the gas price, and according to the code, it will just calculate how much gas it's actually spent. And then if it's smaller than the gas limit you supply or the gas you have, it will just give you refund. If it exceeds the gas supply you have, then your transaction will be just rejected. So here is just how this transaction works. So a hash generation and then broadcast it. And then the minter or miner will just pick up the transaction, include it in a block in order to verify the transaction and consider it as successful. So usually your transaction is also packed with some other people's transaction into a block and being minted or like mined in the next block generation. And the transaction will also get a block confirmation number. So the confirmation number is just the block created since the block that your transaction was included. So the higher the number, the greater the certainty that the transaction was processed and recognized by the network. So basically, that's how it works. So here we can see the difference from the basically the blockchain VM the blockchain VM introduced into the blockchain network, right? So before the introduction of the blockchain VM, blockchain is just a shared ledger, but now it becomes state machine, right? So every time there is a transaction being sent to this blockchain VM, then it changes the states of the blockchain. Okay, so this is the internal structure of the EVM. So it's pretty similar to some other like virtual machine, like JVM or like some other virtual machine, right? So it also has like stack and the memory, right? So all operations are performed on the stacks. So access with many instructions such as push, pop, copy, and swap. So that's how the stack works. It's just doing these operations. And the memory is linear that can be addressed at byte level. So access with like mstore 8 or mload instructions, all locations in the memory are well defined and initialized as 0. So storage here basically is a key value store that store these 250-bit words to 250-bit words. So that's how the data is stored in the blockchain. Okay, so let's see the EVM in a bytecode view. So here is assembly. So it executed this sequence of the actions, but once it's compiled to bytecode, and EVM will just execute this bytecode. So a transaction presents a valid arc between two states. So so it can also be viewed as a transaction-based state machine. And also transactions are also collected into a block. A block is packed into data. From the point of view of states, so the network can be seen as a state chain. So each state, there's a state transition between each block generated. So from the point of view of the implementation, so the network can also be seen as a chain of blocks. So it's called a blockchain, right? So if we ignore the states here, so the state change is actually led by the blockchain changes. From the point of view of ledger, so the network can also be seen as a stack of transactions. And all nodes in this network share the same word state. But also each node in this network will also keep a copy of that world state, so that there's no centralized world state. That's how a P2P network works. Also, decentralized nodes constitute, for example, the P2P network. So external actors can access the blockchain network world through nodes. So for example, there are 10 nodes. For example, for BSC, I think there are currently 21 nodes in this blockchain network. So any external actor can access any arbitrary node in this network and send their transactions or do their transfers. And any nodes in this net, all the other nodes will just validate the transaction. And also the clients have access to this network via Web3 API. So this is a API introduced by Ethereum, but also other networks using EVM also use this Web3 API. And later on, we will show like how this Web3 API is, how we use Web3 API to interact with blockchain. Okay, so I think this is the last part of this blockchain network structure, which are the nodes and the clients, right? So for the network to work in a decentralized way, it needs the distributed network of nodes that can verify blocks and transaction data. So you need the application known as a client on your device to run a node. So why node is important, and a client is a implementation of the EVM that can verify all these transactions in each block, keeping the network secure and the data accurate. So here's a simplified diagram. This is basically the Ethereum. We use Ethereum as an example. So this is a simplified diagram of what Ethereum clients features. It basically has a state, EVM, and the transaction pool. And it uses the proof of work as a consensus mechanism. And after the consensus is achieved, then the blockchain is generated. Okay, so there are different types of nodes. So the first type is full nodes. So it's quite heavy, so that it stores the full blockchain data. And also it can participate in block validation, verification, and also all states can be derived here. But it's hard to sync the full nodes because it stores the entire blockchain data. Light nodes basically just store the header and the request everything else. So it can verify if the data is valid against the state rules of the blockchain headers. And also the archive nodes is basically used to store all these blockchain data but usually it does not attend the validation and the request computation. So here is the picture shows how we actually interact with a blockchain smart contract. So we need the Web3.js, as I just mentioned, which is an interface that is written in JavaScript, so that in the browser we can just directly access a blockchain smart contract and invoke the functions there. And all the requests will go through the node. It can be infer, can be gas, or can be other type of nodes. And then through the nodes, the transaction is sent to the network, and then the network will process it. Okay, so there are different type of networks. So the first type is the mainnet. So mainnet is basically the primary public production blockchain network where actual value transactions occur on the distributed ledger. So which means that every transaction you send in the mainnet, you probably that will affect your real asset. So it will cost money. So usually people will have their program or smart contract well tested in the testnet. So testnet are the network used by developer to test the smart contract before going to mainnet. And since testnet doesn't really have the mechanism of like a mining or like a minting, so we need the faucet to actually give to produce the basically the mock cryptocurrency on testnet. So faucets are just web apps that you can just input a address which you request the native cryptocurrency to be sent to. So here is a link of the BSC faucet. So later on, if we want to do the practice later on, we can just use this BSC faucet to get your first BNB on network. Here's the tutorial we probably will go through later, or maybe after class, that how to create a account and transfer the BNB to the net to the testnet to start our smart contract development. Okay, so here I think here is just a refresh. So smart contract is just simply a program that runs on the blockchain network, and it's a collection of the code and the data that resides at a specific address on the blockchain network. Okay, so we talk a lot about the smart contract. So how to do this smart contract development? We need to first, it's basically programming. So we need to know like what's the language we use for smart contract. So we need a developer friendly language for writing this kind of program. So currently, what we use, what's most used is Solidity. So it's a program language for smart contract on Ethereum and BSC. Okay, so let's take a look at Solidity. So this is the logo of Solidity. So it's actually influenced by C++, Python, and JavaScript. And it's statically typed, and it supports inheritance, which means that you can just extend your contract, right? So for people who are familiar with like object-oriented programming, so this is a very basic idea there. And the libraries, which means that you can just write your code into a library that can be reused in different places. So that's basically like static classes in object-oriented program language, and also like a complex user-defined type. So you can define your own types, such as we all know that in the DeFi market there are a lot of like different tokens. So they are all user-defined types in the smart contract. So here are the resources we provided for you to take a look at this program language. You can take a look later. And here is how this Solidity looks like, right? So it starts with the keyword contract. So contract is the smallest unit that can be compiled in Solidity. So here we can see inside the contract, there are certain fields. So this one is a variable fields. So the keyword public makes a variable accessible from other contract. And this one is a mapping. This one is a mapping variable. So which basically a map from address to a number. And this one is a function. So this one is a function. Is that event? This one is an event function. So events allow clients to react on specific contract changes you declare. This one is the constructor. Constructor is the code snip that only run once when upon the contract creation. And these two are basically the user-defined functions. So the main is namely is just create the coins to a address. So basically send the coins to a specific address. And the send is basically another function that you can just send an amount of existing coins from any caller to address. So these two are basically a user-defined function. So we already know like how a Solidity smart contract looks like. So it's a program runs at a address on blockchain network, and then made up of data and functions. So here we can see these are data, right? All these four are functions. Okay, so what are the data types in Solidity? So there are two types of data. So one is storage, the other is memory. So the first one we want to talk about is the storage. Storage basically is a persistence data. Refers to as the storage is represented by a state variable. These values get stored permanently on the blockchain. So which means that when you declare this stored data, assign a value there, then it's on the blockchain forever. So the reason, so that's why behind this data, you need to pay extra gas fee you need to pay extra gas fee because you are using the node's storage space. So if you are, I think there's another type is that memory, right? So if you don't want to persist the data onto the blockchain, you just want to use the data or variable for the computation. It's basically intermediate variable. Then you just use memory. So there are various of variable types in this Solidity, but most of the types you must be familiar with if you have experiences in other like programming languages. The only unique type is address. It's basically a 20 bytes hex notion with a leading 0x. So that represents the unique identifier of the account in the blockchain world. Okay. So values are only stored for the lifetime of a contract as execution. That's called a memory variable I just mentioned. So since these are not stored permanently on the blockchain, they are much cheaper to use. So, but the storage is much expensive. So in addition to the variable you define on your contract, there are also some global variables. So these two are the global variables. So for example, this block timestamp is basically the current block epoch you can get when the transaction comes in. So it's basically a transaction scope variable, and also message.sender is also a transaction scope variable that you can get when the transaction comes in. Okay, so these are the function modifiers. So there are different type of functions. So basically there are 4 different types: internal, external, public, and private. So internal is that internal functions and state variables can only be accessed internally, like within the current function. And external is that the functions are part of contract interface. They can only be called externally via other contracts and the transactions. And the public functions, it can be called internally or externally. So it's basically a combination of internal and external. And the private functions are only visible in the contract. So they are not defined and not derived in other contracts. And internal, if you're internal keyword, if you're extending a contract, then you can also use that. So it's basically similar to the protect keyword in other programming language. So here are some examples. So here is a function for updating a state variable of a contract. So the parameter value of this type string is passed into the function new message. It's a new message. So it's actually used the memory keyword that indicates that this is a memory variable that won't use any storage in the blockchain, and it's declared public, so meaning that everyone can access it, and it's not declared as view, so that it can modify the contract states. So if it's declared as view function, then if it's declared as a view function, we can see here you cannot modify the storage of this blockchain inside the function body. So here, view is just a promise not to modify state of the contract data. As we just described, the constructor is the functions only execute once when the contract first deployed. Okay, so here comes to the ABI. So why we need the ABI? Because even with the compiled data, it's not enough for the blockchain to understand. So what's the what's the actual different what's the actual type and the input of a specific field function, or for example, here we have this specific field called message, which is string and it's public. So the corresponding API it has its name called message, and it has input. It does not require any input because this is a variable. So which means that you can only get its value. You cannot assign its value. So input is empty, and its internal type is string. And its state mutability is view. So which means that you can only see it, you can only read it, you cannot like modify it inside of this function body. And the type is defined function here, even though internally all these contract field are all declared as function. So here is another type of function is constructor. So let's take a look at its API. So its internal type is also string, which means that its input internal type is string. So which means that this init message is we need to pass string there, and its state mutability is non-payable, which means that when we call this function, we don't need to pay any extra fee for it. And its type is constructor. So constructor is a specific type of the function here. Here is a very normal public function, and it's also non-payable because we don't need to, we don't transfer money when we call this function. And its type is function. It's not view because there's no view keyword here, so it will out the contract stored data. And here is the last function. We just saw it quite a few times. It's a view function, so we cannot change any data inside this function. And basically, this function will just return a string by concatenated the message, concatenated message. Encode the pack the in message and the stored message, which is the stored variable in this contract. So it's here. All right, so it's just I just finished a very brief introduction of like Solidity, but so I think you guys will see a more in-depth introduction or tutorials in the future classes. Here I want to demonstrate is the white matrix blockchain dev tooling. So which namely is ChainIDE. It's a multi-chain IDE that you can just write, test, deploy, compile, deploy, and interact your smart contract in I think it's now support like more than 10 different blockchains, including Binance Smart Chain, Ethereum, IOST, Nervous, Ultron, Libra, and so on and so forth. So this is the UI of the ChainIDE, and we also like provide different endpoint for the chain for different blockchains. So today, I think we mainly will use the bscid.com, which is the chain ID for BSC, to demonstrate the smart contract compile, deploy, and interaction. Here, like White Matrix, not only like provide the tooling of ChainIDE, it also has some other toolings like BAS, which is blockchain service, and also chain classes, which is basically the course platform, MOOC platform you guys are currently using, and also Chain Castle, which is interactive tutorial for multiple blockchain smart contract development. And also we have very in-depth blockchain integration with different blockchains. So we provide the tooling for not only for like developer, we also provide tooling for like analytics tool and workflow tool and the resource management tool for different people like developer, business analyst, and also like DevOps. And here is the structure. Here is the architecture of our like blockchain as a service product. Okay, so last part is some hands-on practices. So in the next I think in the next 20 minutes, I will just demonstrate how to use ChainIDE to write and deploy a decentralized application to the Binance Smart Chain testnet. So let me start a new share here. All right. Can you guys see my screen? Okay. So if anybody can just raise your hand, then that would be good. All right. So look. Okay. I see a lot of. Thanks for your like notification. I already see a lot of raised hands. So okay, let's open the BSCIDE. So this is the UI of the BSCIDE, which is the cross-platform smart contract IDE specifically designed for Binance Smart Chain. So I have already installed the MetaMask, which is the tutorial of the MetaMask installation is inside the tutorial link. So you guys probably can take a look after the class, but I already have it set up. And you guys can also find the tutorial. Basically, there will be a template added later. I think here for you guys to start this week's assignment. All right, so this is a tutorial looks like. So here is the ChainIDE is a online interactive IDE. If you guys you have used like VS Code, you guys might be familiar with it. So the appearance looks quite similar. The reason we designed in this way is try to get people like a bootstrap on this, ramp up on this IDE very quickly. So here is the MD file, which actually like illustrates so how we are going to do today's tutorial. So ChainIDE not only supports like smart contract, it also supports the like the MD file and also like the JavaScript file. So you probably can also like build a decentralized app build the decentralized apps front end in HTML and CSS and JavaScript, and also backend, which is in Solidity in the same workspace. So what we will do is, okay, so let's do it first, a brief overview of ChainIDE. Okay, so upon entering ChainIDE, what you will get is this field, right? And then you can just create a project with any of these templates. If you have already created one project, you can just open it on the left. I already did that, so I will just close that. And after entering this project, so you can just change the project name. Here, I just named it to Binance Masterclass Week 3. Okay, so on the left is File Explorer tab, so that you can just explore all these. You can just browse all these files here. So basically, today we have 3 Solidity files. So first one is Hello World. Second one is token. I will just briefly talk about it. And the third one is a token assignment, which is basically the practice you guys probably want to do later as part of this week's assignment. And in the middle part, it's basically the IDE editor section. So you can just do all this code editing here, such as if I want to, okay, so add one more code here, let's say minter equals MSG sender, right? So I can just add it here. Also, I can, this ChainIDE also supports all these basic functionalities of a modern IDE, such as code completion, right? And code hint, right? So, all these things you can all achieve in ChainIDE. On the right, this part, it's basically the blockchain action section. So what you can do is you can compile the contract, and after contract's compiled, you can deploy it easily with this tab. And also you can browse the transactions you send from ChainIDE. So let's do this quickly now. Before I start in the compilation, I will just let's just go through this hello world contract quickly. So I think we already take a look at it. So this one is the public string message. That is a public state variable that can be read from other users on the blockchain, right? So this is a constructor, as we already mentioned. It will just initialize the it will just called once upon the initialization of this contract. But as it requires a input variable init message upon the contract creation, you need to pass that in. And the update is just to update the message, right? And the concat message is basically just return a concatenated string of the input message in the memory and the variable message in the storage, right? Okay, so let's do a simple demonstration of how the ChainIDE works. So let's do this compilation. So I already did it once before, but let's do it again. So ChainIDE also have this output section that shows the logs of all these interactions with the blockchain. So I'm actually doing this compilation. The compilation succeeded, and we can see the ABI here. So we have like 4 ABI. I think these 4 entries will each have 1 ABI entry here. So we can see update is here, right? And I think message is here. Concat message is here. And this one is constructor, right? We have all these 4 ABI. And if you copy this ABI, you can just, I can just paste it here. This is the copied ABI. All right. After this ABI, after the contract is compiled, then we can go to this deploy and interaction field. We can see here is basically the wallet section. That what we see is we have already connected to this Binance Smart Chain. This is Binance Smart Chain account, which is the account we just created on the BSC testnet. So in the tutorial, you guys will go through how to configure this MetaMask browser wallet, and then ChainIDE will automatically connect it to this browser wallet. So let's do this deploy. Oh, I need there's error here because I forgot to add this init message. Let's say I will just put a world here. So we want the blockchain to serve the world, right? So okay, so we can see the transaction hash is already generated, and we can it will generate a link of the BSC testnet. So we can track this condition in the BSC testnet. I actually see a lot of people are asking questions. So I will just answer them at once in the end of this lecture. Okay, so we can see this one is already being successful. This contract is already being successfully deployed. And here in this transaction detail panel, we can see the detailed transaction fields like block hash, block number, and the other transaction hash and other fields, and it's confirmed by 5 blocks. Okay. Now we can take a look on the message. So we are wondering if our word message is successfully deployed. So let's do it. Okay, so we can get the word, right? And if I want to update this message, maybe I don't want to update this message. I just want to say, let's say hello world. Okay. Hello world. I get hello world here, right? So it's basically concatenated these 2 strings together. So I want to update the message, right? So let's update it to Africa. right? Because the updated message will modify the stored variable in this contract, namely the stored variable in the blockchain, then it will require some, it will require you to pay some gas fee. So I will just do that. All right, so the gas fee is already being, the transaction, you can see the call transaction is here, right? And then the transaction is confirmed here. It's confirmed here. So I should be able to get Africa here. Yeah, it's Africa, right? So if I say, sorry, it's here. It becomes Hello Africa. Yeah, say Hello Africa to all of you. So who are listening to my talk, thanks very much. And yeah, this is how the Hello World contract works. The second one I want to show is it's a little bit complicated, but it's very important, is that how we build token, in the block world, right? So a token usually will have an owner, right? And a token should have a balance, right? So that each address, let's say address represented different people in the blockchain network, should have their own share of that token, right? So for example, I created one token, let's say white matrix token, right? And I want to send it, or I want to share it with some other people. Then I will just distribute the tokens balance to different people. So this is how the token contract works. And there is a function called mint. So it will create an amount of new tokens and send them to the address. Okay, so here we can see the require statement is basically similar to assert statement in other programming languages, just a safeguard a certain condition that you want to be you want it to be satisfied. Let's say only the owner of this contract can mint the token. So the owner will be set at the beginning, right? So owner is just the message sender, which is if I created this contract, then I will be the owner. And also ensure that there is a maximum amount of token that can be mint, right? So otherwise there will be inflation, right? And then here's a balance to record. So each person, like who will own how much token amount. And the transfer is basically another basic functionality. If you create let's say Bitcoin, right, you want it to be transferred to, can be transferred to other people, right? So here it's basically very simple. You have a receiver, you have a amount, right? So then I would just subtract the amount from the sender's balance, and then put that into the receiver's balances. So that's how it works. To save times, I want to deploy and test this token contract, but you guys can take a look later and try it yourself. So I want to go through is the third one, is basically the assignment. So assignment is very simple. So basically here the comments already shows, I'll just make it bigger so for you guys to take a look at it. So these are the 3 steps. So first you need to mint enough BNB to your contract, to your account, so that you can just create the contract and interact with it. And then you deploy it to the BSC testnet and finish the below coding tasks. So the first coding task is, okay, in the constructor, what we want is assign the owner email to this assign the owner email to the contract state, right? So we have this owner email contract state variable, and we have the input variable email. So you just do the assignment, simple assignment here is should be quite straightforward. Here are the mint send functions. You can take a look, but you don't need to implement it here. Here is just another question, which is also, I think, is quite straightforward. I think you just spend some time, then you just can work it out that what I want is just return a string as hello from the owner. Let's say if the owner is my email address, so then what we will get is hello from tim@whatmatrix.io. Okay, so I think you should be able to, you should have remembered that in the hello world, we have a similar thing here, right? So in the hello world, we have, sorry, it's here, concat message here. So this one should be similar to that. The third one is a little bit tricky. It's basically do a calculation that return the first 10 integers that give the input between 0 and 100. And if there's no 10, let's say no 10 integers, then you just return the numbers of, return whatever the numbers in this range. So it doesn't have to be 10 numbers. Okay, and then this is, because this is a little bit complicated, then this one will be the extra question, and they want content points. So so here's a hint that you can just use. Take a look at how a loop works in Solidity, because probably you will need to use loop here. All right, so here is the simple tutorial of like how to like edit, test, compile, deploy, and interact with your smart contract deployed on the BSC testnet. And also there are some other like ChainIDE available here, like Ethereum ChainIDE. So you can also have a try there. All right, so I think this one finishes my current, my today's talk. So thank you very much. And I think it's a little bit lengthy, so I might skip some details in between, but I have provided all the links and the available materials in the slides, so you guys can take a look later after the talk. So thank you very much. And I think there are a few questions I probably want to answer live, right? So oh, thanks. I would just take turns to answer these questions. So let's try answer live here. So I think the first question is from, sorry, my bad English. I need to spend some time to like try to pronounce your name. It's Olu, right? So the first question is from Olu. Is are the nodes in the blockchain networks the same as EVM? No, the nodes is not the same as EVM. So the nodes is basically the actual real world server that contains basically the implementation of, that runs the implementation of EVM. Okay, so hopefully it answers your questions. The second question is from Aomide, right? So is Solidity a backend language? Solidity is a general, I won't say it's a general purpose language, but it's just a language, right? So currently it's only used, I would say, answer live. So currently it's only used in basically in smart contract development, but maybe later it can be used as a backend language as long as somebody can develop its corresponding like compiler to compile it into more complicated scenarios. All right. The third question is from Bisioner. So I just answer live. So how does different nodes know about the existence of each other and how to communicate with themselves? Is there a is there a centralized server where all IP addresses of the nodes are updated or something of that nature? So also where how is the DApp hosted? Is there like a normal website hosted? Are there special hosting platforms? Or actually, you asked us 3 questions. So okay. So I think I will just answer it in order. So how does the nodes know about the existence of each other? So there are different implementation of different networks, but since they each node already keep a state of the world, they obviously know how to interact with each other. There are, for example, different implementation like Hyperledger. They implemented it in a discover way, so that there is a keep discovering these nodes. But there's also some other implementation that each node will be responsible for discovering their pairs. So for your first question, it depends on the implementation, but in most cases, it's a discovery fashion. And is there a central server? Usually there's no central server. Even there is a I say a list of nodes. It's also kept in each node. There shouldn't be a centralized server. If there is a centralized server, that's a different scenario than we talk today. So like Ethereum BSC, it's basically called a consortium blockchain. Also, how is the DApp hosted? So basically, when we talk about DApp, we talk about 2 different parts of DApp. So the first part is its front-end interface. The second part is a backend, which is smart contract. So smart contract is hosted on the blockchain, and the front end is hosted in many different ways, but most cases it's centralized. It's hosted by personal server. So the decentralized app, when we call it decentralized, it's basically because its backend, its logic state is decentralized, but its interface is deployed can be deployed anywhere because its interface won't affect the nature of its decentralization, right? Maybe I have too many questions here to answer, so
yeah, you can filter through the questions.
So, but I'm quite happy to answer all these questions. So probably you guys can contact with me. I think later I will just leave an email there. So feel free to ask me questions. And I'm also in this Discord chat room. So just find me there, or just raise your questions about today's lecture. So is it possible that we can create a room specifically for answering today's questions?
So that might be possible. So I will reach out to Jeff about this, right? And yes, then we'll look at the possibility of doing that. Yeah.
Yeah. So because I see,
yeah,
sorry. Because I see there's really a passion of all these audience. They want to ask questions. So I will try my best to answer all these questions to make sure everybody attended these classes will really understand how decentralized app works. Yeah.
Sure. I'll pass this feedback to Jeff and see if we can just create a channel for that. Yeah. Okay,
cool. So probably I will just try to answer a few more here, maybe 5 more. Okay, 5 more. I'll answer 5 more. If there's no real world identity, it's from Read1. So if there's no real world identity on the decentralized app, how can legal actions be instituted? Or how can dispute be resolved without ascertaining the person behind that app? Okay, so it's actually a very interesting question. So that even though you don't have any real world identity behind that decentralized app, but you probably have some connections between that identity, let's say this like a private key or like address with some centralized like application. For example, if you are using some centralized wallet, right? So then even though the ID is still centralized, but you probably need to connect that with your own your own ID. Let's say your ID card, right? Then that's how people will just find that. So that's also a warning saying that don't really leak your personal information to any insecure website, right? So, but theoretically, if you keep your personal information really safe, then there's no way to find you. All right. Okay, so it's Samuel's question. So what's the Binance Smart Chain trade-off for scalability and lesser gas fee? A whole lot of Ethereum maximalists don't see Binance BSC as a decentralized. Yes, part of yeah. So even though there's always like a controversy between like centralization and decentralization. So I have to say that so we have to admit that Ethereum is much more centralized than Binance Smart Chain, right? Because it has more like a validator, and you can become a validator on your own, right? So, but there's always a trade-off, right? Because the more validator you have, so the more full node you have in its network structure. We all know that maybe later we will just in later structure we will cover a little bit about like different structures of blockchains networks. Let's say, for example, like a Binance Smart Chain is a parallel dual chain structure, right? Ethereum is a like heavy full chain structure. So they have pros and cons, right? Ethereum is purely decentralized, right? Binance Smart Chain is less decentralized, but it achieves much higher like performance. So that's also a direction of Ethereum 2.0 goals, right? So if you look at the proposal of the Ethereum 2.0, so it's actually a trade-off between like decentralized and the more efficient like transactions and the better throughput. So what we want to do is we want to find a midpoint, a balance point between decentralization and efficiency. And we want to make sure that efficiency is achieved. And the decentralization is right at the point so that both can be, it's basically a balance question and a trade-off question. So hopefully my answer can answer your questions. Yeah. Okay, I think, please can one get the PDF of today's class? Okay, of course. All right. So Jimo, so what's the limit of the transaction a block can contain? So usually it varies. So some blockchains defines a blockchain to contain a certain number of transactions. There's a limit, or it will always like produce a block when a certain like a time point hit. So for example, a block is produced every 5 minutes, or there's more than like 1,000 transactions. So it all depends on the configurations, and it's very flexible to be configured. Two more. Let's pick some people from the bottom maybe. There are a lot of okay, there are a lot of questions even not asked today.
Yeah. Do you want to answer live question? maybe
yeah, I want to answer last questions. Yes.
All right, great.
How
So
should I do that?
I'll just open I'll just take maybe 5 questions from 5 people that are raising their hands. Nicholas Ozo, you're allowed to speak, man. Just go ahead, straight to your question.
Hello.
Hello.
Hi, Nicholas.
I'm fine. What I'm asking is that, like some of us that don't have computer background, coding background, how do we cope with this assignment?
So basically, you don't need to worry too much about this assignment is a grade. So the purpose of these assignments is basically to get you familiar with the blockchains. And also coding is just a part of this assignment. There will be a list of like multiple choices. That's all covered in the slides. So that should be good. And the points won't affect that much. The purpose of this assignment is basically get everybody into the blockchain world. Yeah.
Okay, thank you very much.
I'm going to allow Wando Gozo to ask this question. Wanda Gozo, you're allowed to. Can I ask a question now? Wanda Gozo, are you there? Maybe I'll just move on to someone else. EB Aroa, go ahead.
Okay, thank you so much for this opportunity. Thank you, our instructor. Can you hear me?
Yeah, go ahead, man.
Okay, I have a couple of questions, but let me just start from the account part. Yeah, you mentioned that the accounts are in 2 parts. The one that you create your private key to maybe sign with your public key, and the one that can't default when you create a contract. Now, I want to paint a scenario. If the account type is the account type, the one that you create with your private key, do you create the private key, like maybe use a service to create the private key? Then you can sign with your, then
so basically,
okay, go ahead.
Sorry, go. Sorry, so if I want to paraphrase your question to make sure I understand correctly. So you mentioned that is there any way, are you saying that is there any way that you create your private key on your own, right?
Yes, yes.
So basically, most blockchain networks will specify what kind of private key they accept. So there's specific format. So I think it's definitely possible that you can create it on your own, but you need to import that into the blockchain, you need to import the public key into the block network, and that should has a specific format, right? And this is one possibility, right? So because it depends on different blockchain has different implementations. So some blockchains will allow you to create your own private key, such as Hyperledger Fabric, right? Some blockchains, they will take charge of the key creation for you. So you just request can I create a key, and they will just create it for you. But this is kind of dangerous because upon the creation, you don't know who will know the keys, right? So in most cases, I would say the key creation is on your side, and what you need to do is import the public key into the blockchain.
Okay,
and that need to follow specific format. That's for sure.
Okay, please let me just take one more on the transaction part. You mentioned that a transaction calls a transaction. Like, let me paint a scenario. Say, in a case of a phone call, I want to call another number, and in the process of making that call, I'm going to incur some credit for making that call to the next party. Does that work similar to a transaction calling into a transaction? Maybe I want to perform a transaction, like say I want to transfer fund to another account, is that similar to how it works, where a transaction calls another transaction to perform an operation? Then secondly, the account, if I create a contract, which by default it's an account, probably because it's an account, you also has an address property by default. Is that contract address the same thing with the account I would create with the blockchain network? I asked two questions. Sorry, did you get me, sir?
Okay, so I will just answer questions in order. So first question, so are you asking if I make a phone call to another person and tell him to transfer some money, something like that, transfer some money to from another person to me? Is that what you?
No.
What you're saying?
Yeah, I was trying to understand how the transaction happens. So I use a scenario where maybe I have I want to make a call to the next party, and for me to make that call, I need to incur some cost to make that call. So I was trying to liken it to a transaction calling into another transaction to perform an operation where I will incur gas and the process of doing that.
Oh, okay. So yeah, definitely. So if you want to call the chain of transactions, then you need to be responsible for all these gas fees. That's for sure. But if these transactions are packed into the same block, then the gas fee will be. I think the gas fee will be reduced, but you still need to pay the gas fee for both transactions. Yeah. Is the answer? And it's totally possible in your case. Yes, it's totally possible in your case that you can call two transactions in what you can call another transaction in your original transaction. You just need to specify your gas fee there, and these two transactions will be calculated. The cost will be calculated based on your initial gas fee that you specified.
Okay, fine. So, but I also asked the contract account. Is it the same thing with the blockchain account? Thank you.
So
I got a question on the question. Yeah, the contract account is the same thing as the blockchain account.
No, it's different. So as we just discussed that the contract account will have two more extra fields, right? So you can say they are the same data structure, but for the blockchain account, you don't have these two extra fields are empty. But for contract account, these two fields will have their values. That's the difference. So they are different.
Okay, how are they synced?
Sorry?
How are they synced? How are they synced? How are they connected? How do the two accounts connect or communicate?
You mean communicate with your
smart contract? How does the smart contract account communicate with the blockchain account since it belongs to one entity?
Oh yeah. So basically, since you have this smart contract account in the blockchain, right? So it's similar what you do the transfer. You need to send some money to another account. It's similar. You just send some requests to that account, right? And with the data, you specify, okay, so what's the function I want to call? Then that's how it's interacting. It works the same way as like you have two external accounts. You just like transfer money, right? It's the same thing. You can also transfer money to that account. That's totally doable. But you have extra functionality to send a request to that account. Say I want to call this function.
Thank you so much. Thank you so much. Thank you so much.
You're welcome.
Yeah, thank you, Ben. How many more questions can you go for, Tim?
I think I'm happy to answer more.
Okay.
I don't know if there's a specific like time limit to this for this class, but let's do 3 more questions maybe.
There's no time limit. It's all on you, man. So let's allow Toyosi Bakare to speak. You go ahead, Toyosi, unmute yourself. Hi, Jason.
Can you hear me now?
Hello.
Hello?
Yep.
Yeah, can you hear me now? All right.
Yeah.
So
Go ahead.
the question I want to ask is about the gas price, I mean the gas fee. Sometimes when we are using the Ethereum blockchain, we notice that the gas price might be maybe a little bit cost, and sometimes might be normal, sometimes might be even very low. You don't expect, you can't say that you are going to meet the gas price at this particular price. And when Ethereum became very cost, the gas fee became so high. And that is the reason why most people are moving to BSC right now. And I'm just more concerned about the gas fee. What caused that? Is it caused by the miners or the price of the coin?
So there are various factors of the gas fee. The first one is the network status. So if it's in the network status, there are a lot of queued transactions, right? So which means that the gas fee will be much more expensive. The second, there are some other factors like the miner status, right? And sorry, miner status and also the network status. So these two are the main factors, and also the code length, right? So the code length, there are more and more like big contract execution, so it becomes more lengthy, and the computation power required for compute these things is more complicated, right? And also there are a lot of transactions being clogged in the queue. Then it takes more time to get to the transaction being processed, right? So I think to answer your question, three main factors. So currently too many applications deployed on Ethereum, right? And Ethereum's design, right? Because the full node is very heavy to do all these computation, and also the network status, and also last one is the contract, right? The contract become more and more complicated. Yeah.
All right. And
I think he dropped.
Yeah.
In the middle. Yeah.
Let me allow Kashif to talk. Kashif has a question. Go ahead, Kashif.
Hi, Tim. Thank you so much for your time. I just have a pretty simple question, and it's how do we improve network congestion, and how does the blockchain pick up poorly written deployed smart contracts that would become costly if we were to use those public functions in our contract logic?
So public function, if it's view, so that won't take any time because it won't be calculated, right? So so if that you're asking how to improve the network congestion, there are actually many different attempts, like Ethereum version 2. So given current status in Ethereum, there's nothing you can do. That's a bad thing of like blockchain, because once it's fixed, it's fixed. So you cannot go back, okay, I want to change the logic. It's impossible because you need to change all this consensus, right? So there's very little we can do to existing structure. The only thing is that we build up a new different structure of the blockchain network. Let's say, for example, like the Binance Smart Chain is a dual chain. So one contract chain, one like a data chain. So that's one attempt, right? Smart chain attempt. Some other attempt like layer 2 or like Ethereum version 2, there is something like sharding, right? So sharding basically that they only run the they only run the transaction in a very local area. So that limits number of validators to attend into this like validation. So that's also accelerated the network condition. So various attempts, and most of these attempts it's very interesting. And most of the attempts are actually like experiences learned from like traditional like centralized techniques. So for example, like sharding is basically a database techniques that's applied to like distributed database, right? So now it's being introduced into Ethereum v2 to solve this network congestion problem. So to answer your question, currently with existing structure, very little we can do. We can only to add more like plug-in or add-on something like layer 2 things there, or we create an entirely new structure like smart chain or like version 2. Yeah.
Okay, thank you so much.
Yeah, welcome.
All right, we'll take a few more questions. So Charles Chiakwa, go ahead and ask a question now.
Yeah, thank you very much. Hi, team. Thank you for this wonderful session. So my question is, I heard you say when you deploy a smart contract on the blockchain, it never changes. Like you can't change it again. It's already deployed. So I wanted to ask where, I don't know if I'm right, but I think I heard you say that. But I don't ask, how can companies do an update to a smart contract? Like say a new logic that they want to add to their existing smart contract. If it's already deployed in blockchain and it can be changed, how then would they do that update?
Sorry, I think in the middle, sorry, Charles, in the middle, I think my
Okay, can you hear me now?
Earphone cut off. So can you repeat it? Like I just hear it like it's not cannot be changed. What's the other part? Yeah.
Yeah, can you hear me now?
No, yes, it's much better.
All right, cool. So I was asking, when we deploy a smart contract on the blockchain, can it be changed? Can we have like changes done to that smart contract if it's already deployed to the blockchain? And if it cannot be changed, how then do companies do an update to an existing smart contract that is on their blockchain? Say they have a new logic that they want to add, how then would they do it? You know.
So basically, there are many ways of solving this problem, but theoretically, when you deploy the contract to the blockchain, you want to change the logic. That's almost impossible, right? The only thing basically you can do is you want to do the migration. So the migration, for example, you have the data stored in the smart contract, right? So you want to migrate the data to a new contract. So that is, you write a new contract, right? And then you read the data, because as we mentioned that we can do contract to contract interaction, right? Then you read the data from the old contract and put it into the new contract. Then you finish this migration. Yeah.
Oh,
that's the most common way of doing this.
All right, thanks.
You're welcome.
All right, great. So we just take a few more. And just see a lot of hands are raised. John D. Vincent, please go ahead and ask a question. Hi, John D. Is it John Vincent?
Hello?
Hi.
Can you get me?
Yeah, we can hear you now, man. Go ahead.
Okay, so I want to ask a question. Is Solidity the backend and also the database?
Is Solidity what?
The backend and also the database, like the information about the users. Yes.
So you mean Solidity is used for database, or it's blockchain used as a database? Solidity, right?
Okay, the language. So it connects to the database. Like, okay, so the blockchain is the database.
So you can use it as a database, and the language can also support, I mean, your usage for database, saying like I can store data there, right? But it's not if you are saying modern database, it's not like blockchain is not optimized for a database, right? Because saying database, so you are saying if you are saying a relational database or like a NoSQL database, right? Yeah. So the relational database is very good for querying, and NoSQL is very good for scaling. But blockchain is not designed for any kind of this kind of data querying or like scaling optimization. It's more about the data integrity, data persistence, and immutability and auditability. So if you're doing query,
yes,
it's if you're doing query, it's not good. But if you are more focusing on data quality or data like saving, then that's a good data storage. I would say it's a good storage rather than a database. Yeah.
Oh, okay. Okay, I understand.
All right, great. Let me take a non-Nigerian. ChainIDE. ChainIDE, hope I pronounced your name correctly. You go ahead and ask a question now.
Hi, Tim. Hi, everybody.
Hi.
I just wanted to know, is there a way that you can subsidize the requester's gas fees? That's maybe one of the questions I have.
So you mean the request gas fee? What you can
so when you're interacting, yeah.
Mm-hmm.
So I guess when you're interacting with a contract, that there's a sort of a cost
Mm-hmm.
involved, gas cost.
Mm-hmm.
So can the contract itself pay part of that gas fees?
I don't think there's a way you can. If there the goal of your question is basically asking, is there a way to saving a contract fee? Yes, there are some way. There's already tools that can get the current network congestion to suggest a best gas fee for you to in a really good point that you can let the transaction get through quickly and then pay at least the gas price, right? But to have some other way, once you specify your gas price, then there's nothing you can do to save the gas fee.
Okay. Just two more questions, if that's possible.
Okay.
The other question I have is, so if you as a requester sets a gas limit, okay, and if that gas limit is reached, the transaction is rejected, will you get back your gas fees, or how do you know, how to set your gas fees?
So this is actually a good question. So to be honest, I forgot. I forgot whether you are going to get it back or not. But I think there's already document there. You can take a look. I guess if I remember correctly, you won't get it back. Will you get it back? I think it's actually a good question. So you can take a look on the online documents.
Okay,
yeah.
Cool. Last question is, so if you've deployed a contract, okay, onto the blockchain, be it Binance Smart Chain, and then you deploy a second version, okay, a newer version, is there a way to decommission the older version so that you cannot interact with it?
No.
No, okay.
So if you're talking about Binance Smart Chain specifically, no.
Okay. Okay, cool.
But there are some other blockchain implementation you probably can do that. So you can upgrade the smart contract so that the older one will not be there. There is some other blockchain does this, but BSC no.
Okay, cool. Thank you very much. It's very entertaining. Thank you.
Thank you.
Sunshine. Let's move on to David Ihago.
Now can you go in the pool?
Hello.
Hello.
Yeah, go ahead, man.
I just need to get the differences. What's the main difference between Ethereum and BSC? If Ethereum already existed, why did we have to why did we get BSC? Why was BSC created?
I think I already answered a few part of your questions in previous even in slides and also in other people's conversations with other people. So this is actually a complicated question. So it's like a question. So we already have a train. Why do we build a car, right? Why do we invent a car? So to answer this question, basically Ethereum is built very long time ago, right? So it has its drawback. So let's say network optimization, right? And also a lot of efficiencies, right? And BSC is built on top of existing Ethereum's technology. Let's say it actually like leverage EVM, right? And Solidity, right? And we want to say, okay, is that Solidity is a good choice? We don't know, but Solidity is the choices that the most developers used to. So after Ethereum, so most of blockchains will always support Solidity. I think that's a power of the habit. So BSC also supports Solidity, also supports EVM, but it mainly focus on the problem of like efficiency and the gas fee. So that's a difference between BSC and Ethereum. That's to the end user, that's the biggest difference. And internally, there are more differences because Ethereum itself is open source. It has white paper, all these things are there. And BSC, as I said, is a dual chain structure. So the structure is also different, right? So you have, I will say BSC and Ethereum are two different blockchains. They are totally different in terms of like design and all these things. The only thing they share the same is the only similarity they share is the EVM, how EVM works, and the program language, so Solidity. So the reason of that is that we want to, especially for BSC want to support the existing developer as much as possible, because the existing developer already get used to Ethereum, right? Yeah.
Okay, thank you.
You're welcome.
All right, cool. Okoli Purity, please go ahead.
Give me a few seconds. I want to drink some water.
All right.
Hello. Thank you very much for the lectures. It's quite yeah, I'd want to ask a question. I'm just curious. Before prior to this time, we're writing code. I understand Solidity, it's a new language. And then so I was just curious. I wanted to know, what other language were they using before? Was it JavaScript, C++, Python before Solidity? Thank you.
So, okay, so it's a new language, right? So are you asking, so what's the difference, or like why we need a new language?
Yeah, why need of a new language, and what language were they using before now to write code?
Okay, so the reason of Solidity to be introduced is that Ethereum is basically a totally different new structure, right? So it has its own VM, right? It has its own VM. It has its own like structure. So I think Vitalik at the beginning also tried to use some other languages, but since there's a lot of limitation in blockchain, it's not limitation. It's like in blockchain at the beginning we want to limit the user to do certain things, right? So we don't want them to, for example, JavaScript, Python, they are all like generic program language. So you can define like a very large data structure. You can define a very large range of like arrays, right? So, but in blockchain, the resources is limited. So we don't want developers to, expand to use all this limited resources. So that's why a new language is introduced that has a lot of restrictions here to make sure that all this, it's better designed for EVM and all these resources. If you take a look at the Solidity, there are a lot of restrictions here. So they want to restrict the way people are using the blockchain. But as we are understanding, as the infrastructure and the structure developed, there it will become more and more open. Maybe in the future we don't use Solidity, we use some other different languages that almost as full feature as much as possible as Python as JavaScript. But at current stage, at that stage, actually, back then, there's no such like infrastructure. So that's why Solidity was introduced. It's just a limit people into a limited scope that's specifically designed for, that scope is specifically designed for blockchain computation. But in the future, as we know, right, Hyperledger Fabric is also blockchain, right? It actually supports JavaScript, Java, Go, Python. I think Python is also supported. Yeah, maybe Python is not, but these are all full-featured generic purposes language. So we already have that examples. So, I mean, to answer your question, yes, Ethereum, when it was invented, it was designed to specific scopes. So that's why they need Solidity. But when the scope is get more and more expanded, then in the future, there will be new language introduced and maybe have the same features as the generic purpose language.
Thank you very much.
You're welcome.
All right, cool. Thank you, Purity. So we have Victoria Aruna. Go ahead and ask your questions. I'm letting the ladies in.
Good day, everyone.
Hi, Victoria.
Hi. Okay, so I wanted to ask. You mentioned JavaScript, C++, Python as the front end for development, and Solidity for the back end. Where does ChainIDE come in? That is one. Secondly, for immutability of smart contracts, you gave us an assignment. That assignment, can we take it as a smart contract? And if we get it deployed, does it mean that we cannot come back and change our answers and deploy again? Those are my questions.
Okay. So the first question is how does ChainIDE serves between the smart contract and also the front-end languages, right? If I'm asking correctly. Yeah, okay. So basically ChainIDE is mainly focused on smart contract, but we are now also adding front-end support such as HTML and JavaScript, and that will be released soon. I think this week. No, next week. So in the later courses, you will be seeing like how people are actually using the ChainIDE to do this like a full lifecycle development of a decentralized app. So that's how we stand on. So we want to serve as much as possible and cover as much as possible of the developers, not only developers, but all the blockchain users' usage. Currently, we're starting from developers' perspective. So that's currently how it stands on. To answer your second question, when you deploy a code to the test network, you don't need to worry, just deploy it. It won't cost, because the only thing you need to worry is the cost. The cost is free. You just get the money from Faucet. When you deploy one there, you just do another deployment there. It will give you a new address of that contract. Obviously, you cannot change the old one, but that doesn't really matter. Yeah. So I think, sorry to all of you guys. So it's already quite late here. So
yeah,
maybe I will just do the last question. Yeah.
Yeah, last questions, Tim. So who do I give the last question to? Let me see. Let's see. A lot of hands raised. Let me give it to Junaid Salat. Please ask a question. Go ahead. Go ahead, Junaid.
Hello, can you hear me?
Yep.
Yeah.
Yeah, thank you for the brief introduction and the lecture. So my question is, as you mentioned, Web3 library is used to communicate with the Ethereum network, right? So from my point of view is like I'm learning, so might be stupid question, but so Solidity is used to communicate with the Web3 library, and the Web3 library is communicating with the Ethereum network on the the bags, right? So for us developers, we write and deploy on Solidity, and it communicates with Web3, and Web3 communicates with Ethereum network, and it goes same for the Binance Smart Chain.
No, I think the order is flipped. So basically, the Solidity is not communicated with blockchain. Solidity is the code that runs on blockchain. So you're writing Solidity and compile to the bytecode and you deploy bytecode to blockchain to run it, right? So Solidity is not the code you use to communicate. The code you use to communicate with blockchain is actually the thing you call the Web3 library. Right, so you in your JavaScript you use a Web3 library, right, and communicate with blockchain, and also you need some other tools like a MetaMask to communicate with the node, right? So that MetaMask basically provide a Web3 implementation. So that's the thing, and in ChainIDE, the reason you can interact directly in ChainIDE is that ChainIDE already implemented the Web3 connection for you, so you can just directly interact with them. Yeah.
Right. Thank you.
So last comments. Sorry. So if you want to do your own interaction with blockchain, then you need to download the Web3.js and write your own code in JavaScript. Yeah.
So I get it. Like on ChainIDE, we use ChainIDE as our IDE, and if we dev on the local host or our development machine, so we use Web3.js, right?
Yeah, you need to build your own client. Yes, ChainIDE already built that client for you. Yeah.
Got it. Thank you very much.
Okay.
Just last thing about the you mentioned the BSC Binance Smart Chain layer 2. So how is this different what the currently we have right now?
They are different. BSC is very briefly. So BSC is just a lightweight dual chain. So one chain is just purely do this smart chain execution. So the very heavy validation will be done separately. So that's why it's fast. And layer 2, it's more complicated than what I can explain here. But basically, what it does is it's directly interact with the native blockchain, and then go through the top layers. So that's why it's faster. Yeah.
All right. Thank you very much. That's all. Thank you.
Thank you,
Okay.
Thank you, Tim.
Thank you very much.
Keeping it down. Yeah.
Okay. So
go ahead.
Oh, sorry. So I want to have my last words. So it's not last words, but last words for today's lecture. So thank you very much, and I've really enjoyed to present this topic, and all the slides and will be updated later. And I think maybe later tonight or tomorrow, the assignment will be updated in the Chain class. So thank you again for all the the audience from the other side of the earth. Thanks. Yeah.
All right. Thank you, Tim, for this, and thank you guys for attending. See you guys next week. Bye.